Hi everybody. Back to go over the next two pages with you in our study guide, starting with question 28, which is asking us, according to the periodic table, which element is in the same family or group as chlorine. So families or groups on the periodic table are vertical columns. So once we find where chlorine is, among the few elements that they showed us, we can see that iodine is the only element of these choices that are in the same family or group. The next part of the question asks about periods, which go in horizontal rows. Question 29 is asking us which element contains 22 protons. To answer that question, you'll need to remember to look at the periodic table provided for you. So the element with the atomic number of 22 is the one with 22 protons. That's how I knew the answer was titanium. The atomic number tells us the number of protons. The next question gives us a lot more information. It asks us about an atom with 12 neutrons, 12 protons, and it asks us for the mass number. We actually don't even need to look at the periodic table for this one because mass number is the total particles in the nucleus. Remember, electrons are tiny and negative, so their mass basically doesn't count towards the mass of the atom. That's how I knew to add the mass of the 12 neutrons plus 12 protons to get the mass number of 24 for that one. Question 31 in the study guide is asking us about isotopes. The isotopes are given us mass numbers here. Carbon 12 has 12 total particles in its nucleus. 13 has 13 total particles in its nucleus. Carbon 14 has 14 total particles in its nucleus. And to make it carbon, every atom of carbon in the universe has 6 protons in its nucleus because its atomic number is 6. But what makes these isotopes different is that they have different numbers of neutrons in the nucleus. So the only thing that's different about one isotope for the other is how many neutrons there are. The next question, number 32, this is one that a lot of people tend to have trouble with. Number 32 says, do any of these atoms are any of these atoms of the same element? And the answer is yes. As we just reviewed, they have different numbers of neutrons, so they're isotopes, but because they have the same number of protons, they're atoms of the same element. The element with the atomic number of 8 happens to be oxygen. Not that they asked us to identify it, but we could if they did. Moving on to number 33, the noble gas krypton. All the noble gases are in group 18, and everything in group 18 has 8 valence electrons, which is a full valence shell or a stable octet, which means that it is inert or that it won't bond with anything else at all ever. But 8 is the magic number we need to remember for a full valence shell of electrons for those noble gases. The next question is asking us about bromine or any of the elements, any of these halogens here in group 17. Because they have 7 valence electrons, they need just 1 electron to get to that stable octet. So that's why they'll form the ion of -1, bromine and all the other halogens, including fluorine and chlorine. The next question is asking us to look at a Lewis dot structure, but don't let that confuse you. That just tells us some information about the chemical bonds. As I can see here, there's 2 oxygens and 1 carbon, so my formula is CO2. In a different example, if I had one that looked like that, the formula for that would be CF4 in a different example. Both of these examples actually happen to be bonded to each other covalently because they're a nonmetal to a nonmetal. Remember, co means share when a nonmetal is bonded to a nonmetal. And this compound is, of course, carbon dioxide. The prefix di means 2. And then my other example over here is actually carbon, Sorry, it's hard to write with my phone in my hand, but it's carbon tetrafluoride because the prefix tetra means four. So that tetrafluoride tells us that there's four fluorines for each carbon. So that molecule would be named carbon tetrafluoride. So that's it for that page. Moving, oh goodness, sorry, I forgot that example was on the next page, so we already did this one. CF4, they're bonded covalently because it's non-metal to non-metal. We got that tetra means four. And moving on to this question, number 38 in sodium chloride. The chemical for sodium chloride is NaCl, no matter where it is in the universe. So that's why that answer was yes. Question 39 is asking us to look at this chart and tell which equation is balanced. And the only one that has the same number of every element on both sides is equation 3 here. If I take a quick peek at the first one, I can see that the first one has an unequal number of sodiums. That's how I know that one's not balanced. The second one has an equal number of hydrogens on each side, but it does not have an equal number of it doesn't have an equal number of oxygens on each side, so that one's not balanced either. Finally, the number 4, my Na is sodium. My sodiums are balanced. My OHs are balanced. My magnesiums are balanced as well, but my chlorines are not. So because even just that one element is unbalanced, that whole equation is unbalanced. So that's how this one that has just one magnesium and 2 chlorines on each side is balanced. Moving on to number 40, which we've balanced here for you as well. The coefficients that would balance this equation would be 1 of this molecule, 2 of this molecule, 1 of this molecule, and 2 of this molecule. So to quickly review that, that gives us, let's see, 1 carbon on this side, 4 hydrogens on this side, because 1 times 4 is 4. We get 2 oxygens on this, I'm sorry, that's wrong. 2 times 2 is 4 oxygens on this side. And over here we have 1 carbon on this side, 2 oxygens in this molecule. We have 4 hydrogens. It's early. Because 2 times 2 is 4, and then we also need to distribute this 2 to this oxygen and add these 2 oxygens to these 2 oxygens. So I actually have 4 oxygens on this side, so my carbons are balanced, my oxygens are balanced, and so is my hydrogen. So those coefficients are all I need to identify to balance that equation. Question 40, I know I made a mess here. Question 40 is asking us about the reactants. The things that react with each other are going to be whatever is before the arrow in this equation. And then the products are going to be whatever is after the arrow, in that same equation. So here we just looked at the coefficients to balance the equation a moment ago. Number 43, moving on, is asking us if we activate an instant cold pack. Water mixes with a chemical inside the pack and it gets very cold. The prefix exo means out, as you may remember, like an exoskeleton. So if the heat were being released and this were heating up, then it would be exo, but that's actually not the right answer for this one. It's endothermic. Endo means inside, like an endoskeleton on the inside. So because the heat is going in or being absorbed and it's getting cold, that's an endothermic reaction. The form of energy that's usually released is heat. And another good vocab term on here that we should review is solubility. Solubility basically means dissolvability. So if I want to dissolve some solid sugar in liquid water, I could add heat energy to melt that sugar. Heat energy. These last few actually are not going to be on our final exam, so we don't need to worry about the pH problems, but I will remind you that speed and velocity are basically synonyms. The only difference is that velocity includes direction, which can be represented by a vector, which is of course an arrow that shows us magnitude or amount, and of course direction. So I'll see you back soon to review the next page of answers. Good luck studying, everyone.